I'd now like to introduce Amol Phadke. Dr. Amol Phadke is the Faculty Director of the India Energy and Climate Center at IECC and at GSPP, and a staff scientist in the Electricity Markets and Policy Department at Lawrence Berkeley National Laboratory. Welcome, Amol.
Thank you. All right. Um, it was really lovely to hear the previous speakers and panelists. So today I am moderating a session which is of a bit of a controversial topic, I would say, is that can artificial intelligence be truly net positive for climate? And we really have a esteemed panel. We have Deepak Garg, we have Mihir Sarkar, and we have Richa Mishra, and I'll let them introduce themselves a little more. So here is kind of the big picture context setting for the panel, given the expertise that we have here. So the first question that we have is in terms of its how are we powering AI? The reality today is that I was just reading the news today, which is basically the Louisiana Public Utilities Commission rapidly approved one of the most ambitious gas projects in the United States. Gas power generation is as bad as coal if you actually count its methane emissions. It's a 5 gigawatt, $22 billion investment entirely to power data centers from Meta. So, yes, we need to figure out how to actually power AI sustainably given the kind of the arms race in deploying AI rapidly. That's kind of the first theme that I would like the panelists to cover. The second thing I would like to cover is that AI is where infrastructure, the dreams meet realities of infrastructure, right? Transmission takes 15 years to build. Interconnection, yes, we have all this clean energy technology that is waiting to be connected to the grid. We need clean power. So, on one hand, we are deploying gas power generation to power AI, and we have trillions of dollars of clean energy assets waiting to be connected to the grid, waiting to be approved. It takes forever to do the interconnection studies. It's just a very different reality of how fast we can deploy infrastructure. So it appears that we are in a very different world. So the second theme we wanted to cover was that can AI actually help solve some of the techno-economic infrastructure problems so that it actually helps fastly integrate clean energy that it actually desperately needs to power AI. And the third aspect is that what else is out there? Like we covered how to power AI cleanly. We want to see if AI can actually solve some of the utility problems to let it connect clean energy quickly. And lastly, what are other high impact areas where AI can actually, solve climate issues? So I would start with Deepak. So I would let each panelist kind of introduce themselves and kind of give your own perspective in any of these themes. So please take a bit of time to introduce yourselves and share your perspective because this is also like you guys are the leaders in the field. Or if any other big kind of pressing theme that I have not covered and you would like to share with this group, that's also uh, fair and square. So let me start with Deepak.
Thank you, Anmol. Anmol, thank you for putting me on a spot first. Okay, I think rather than me, I think Mihir is and both Richa will able to double click on this. But okay, I'll take it the first, pretty much on me. But just Deepak Garg, chairman, co-founder for the SEW.ai, started the company, and Anmol to the same point, I started the company focused on a vertical energy utility. I'm sorry to say, but it was a non-sexy 15 years back. Till 5 years back, nobody wants to talk. Everybody wants to talk about, and I know a lot of people are from Bay Area. Everybody talk about Google and all the big ones, Amazon and the world. And when you talk about the energy and utilities, what is that? I go home, I get power and water and natural gas. What's a big deal in that? And now suddenly the whole world from Wall Street to everybody talking about energy and utilities are the most important assets, because to compute AI, you need the power and the water. And I think the good thing is everybody was focused on AI, which is the output, but nobody think about what empower AI, what power AI, and that's really been our focus in last 15 years. And we, as a company, provide a digital platform vertically focused and from AI context standpoint. Today, we are in 47 countries, work with a 500 plus energy utilities, the biggest water, power, gas utility in the United States, to India, to New Zealand, to Australia, to all. We work with them. We think about, I don't want to double click on that. We are the Amazon for the utilities. We empower, we connect billions and millions of customer end users to make sure they understand what the energy company, Mihir is definitely part of the ENGIE group, how much hard work a power, water, natural gas company does, to really empower our home or our commercial so-called data center or manufacturing unit to work and get what the outcome is. And just quickly on what been our focus and what's we seen it, we always knew that this industry is very important. The power and water demand and supply is the first time in last 5 years people see the big imbalance. And more, you said that the renewable and the climate is a one side. We talk about that. We need a 30% goal. We need a 40% goal. Some countries want 20% goal. This is like really an infinite variable equation. When the power sector, and I know that a lot of people understand the power right now. I don't want to go through the natural gas and the water side on that. In the power sector, what is happening is in the last 10 years, you've seen it, everybody pushing toward renewables. What it does is the main base load is getting completely variable. So when I integrate with the solar, when I integrate with the wind, I'm actually, whatever is my current demand is, I'm making that variable. And on top of that, the consumer side, consumers start using more power in last 10 years because of the EV penetration is happening. We are all adding more and more people on the earth. So there is no way this particular industry will get the less demand. And on top of that, thank you for AI. Data center, you already said that. Utilities are getting the biggest pressure to meet that demand, And while transmission, distribution side and generation side take years to build to even meet the 5 to 10% extra demand, while we are forecasting 40%. So I'm just quickly on us. We work with the global utilities, government, Fed, or state to ensure that the all increasing demand of the water and power, is happening. We can solve working with them in our vertical AI native platform to bring people and AI together. Because if the people get intelligence about how to use it, when to use it, they can help the utilities and utilities can help the ongoing.
Right.
Because otherwise, this cannot be balanced because we don't have any time to solve this problem. Cannot be solved just like that. So sorry, that's why I said, don't put me on a spot. I will be really taking more time, but I'm very excited about seeing Mihir over here, and he's definitely been a part of the great energy company in Europe, your ENGIE group, and they have a multiple.
All right, great. No, thanks, Deepak. So I want to kind of move next to Richa, and if you can quickly introduce yourself and share your top line perspective, that will be great. And then I will move to Mihir, and then I'm going to trouble all of you with some hard questions. So you get to kind of do your spiel a bit, but then I'm going to put you guys a bit more on the spot as well. So over to you, Richa. What's
Thank
your
you so
take?
much. Yep. Thank you, Amol, and thanks, Deepak, for a great introduction. I am Richa. I am an engineering manager for AI infrastructure at Meta. My team and I work on the physical layer of the AI infrastructure across our global data centers, which includes servers, power, cooling across the hundreds of thousands of racks. So our work exists at the crosshairs of energy consumption, how we model for it, and the opportunities for energy savings where we can make it. So whenever the question arises of can AI be net positive for the planet, our approach is to have it with a systemic mindset of an engineer. What is the system? What are the inputs, the outputs, and the losses that we're having as part of it? How can we make those inefficiencies better? So I'm here to give the perspective on where our focus is when we look at maximizing every watt of power recovery, ensuring reliability of large-scale AI infrastructure, holistic management of fleet efficiency, and preemptively diagnosing issues using modeling and simulation techniques. So,
Great.
yeah.
Thanks, Richa. And over to you, Mihir. What's your kind of top line take and where do you sit in the ecosystem?
All right, thank you, Amol, and thanks, and great to be on this panel, and thank you, Amita, for the invitation. So hi, everyone, great to be here. I'll do a quick introduction on my background. I think I've tried to embody the idea of Indiaspora through my career. I was born and raised in Paris, where I'm based actually at the moment, and I've spent quite a bit of time living and working around the world. I worked in India and in Belgium on different things like semiconductors, speech recognition, automotive systems. Then I was at MIT, where I did research at the Media Lab around applied AI and innovation. Did some entrepreneurial ventures in Silicon Valley and in the UK. And a few years ago, I decided to come back to Paris, where I joined ENGIE, which is an energy utility, which is focusing on the energy transition, because I wanted to work on something with a bit more real world, large scale impact. And energy, like we're all seeing, is obviously right at the center of that at the moment. So today I lead AI at ENGIE, where we're trying to take AI out of the lab and embed it into actual energy systems. And that can be renewables, it can be industrial assets like power plants and storage, transportation, distribution, both for green electrons, but also molecules, gas and its derivatives, green gases. And we're trying to make those more efficient, more flexible, and lead to lower carbon across the full energy value chain. What I found interesting in the earlier intervention of Professor Majumdar earlier today was that he mentioned that AI is an accelerator for the energy grid. And I think the way we really see it is a lever for more resilient, cleaner, and smarter energy systems. So overall, let's say I think my work sits at the intersection of AI and the energy transition. And I think that's the paradox at the heart of today's discussion. The fact that, on one hand, AI is seen as part of the climate problem because of its growing energy footprint, and the fact that data centers, through training inference, are accelerating the electricity demand. But at the same time, uh, AI is an optimizer for energy systems, and we see it through use cases, and we can go over in detail around things that we use AI for, like forecasting, for example, forecasting production, but also consumption, for better integration of renewables, like Deepak mentioned, is a important topic. Grid balancing and flexibility that leads to stability and lower losses. We try to flatten peaks by using AI for demand response, for example. And overall, between operational efficiency and energy efficiency, I think those are the two main pillars by which we can run an infrastructure with less waste, less downtime, and lower emissions. And then the third aspect, which I think is growing and is a new way to use AI, is thinking of AI as a system designer. And maybe that's, to me, the most exciting, the frontier field in which we can use AI. Things like prospecting for land for renewable assets or storage assets, designing grid architectures, and there's a lot of work in the US and around the world on smarter grids, but also looking at AI embedded into Google X, the Moonshot Factory's work on Tapestry, for example, which is about optimizing the grid. Then planning flexibility and storage with more and more distributed assets around not only production but also consumption, with electric vehicles, for example, as one of the assets that's both a storage device but also consumes electricity. So just about optimizing the system, we're trying to design the system itself using AI, and I'm happy to go into more concrete use cases.
Great. Thanks everybody for that fantastic introduction. So let me kind of sharply put one question in focus, and I would share my perspective, but also kind of get real answers in terms of how to address this. So, as I mentioned before, there is a lot of talk of sustainability. There's a lot of talk about net positive versus net negative. Today, the reality is AI is driving a massive boom in build out of natural gas based power plants. So, our own research shows that given the dramatic declines in solar and battery storage cost, if those assets work with combination with existing gas plants, there is a way to solve way to meet the AI energy needs, and we have some research on that, which I have shared. Um, but I want to get to say each of one of you, or if you have any perspective, is that the reality is that a massive gas build out is taking place. Now the question is, what would you do, Mihir, if say to flip that, where say in 2030 we are no longer building massive amounts of gas plants to power data centers? Like, what would it take?
So I think the boom in the AI data centers and energy demand around those, there's a quick and dirty way to power these, which are gas power, the thermal powered power plants. I think that the transition to greener means of energy production are both incentivized by cost but also by regulations. And we've seen, for example, in the past few years, the IRA, for example, that was implemented by the previous administration, generate a boom for production for new power plants in wind and solar across the US. We're seeing the same kind of demand across Europe and certain parts of Asia as well, both by implementing solar, wind, leveraging existing hydro power plants, for example, in Brazil, which is a huge there's a huge production of hydro based energy, but also using storage to limit the intermittency of those kinds of energy. And those that combination is a bit more complex to manage, and therefore I think it takes longer investment cycles than thermal power plants. But I think in the long run, that's the shift that needs to happen in terms of what's the regulatory frameworks that will incentivize companies to invest in those kinds of projects.
Great. So I think I'm going to ask you, Richa, like, Meta and several others, it's not just Meta, several other tech companies are, uh, they're of course doing a lot on sustainability, but on the bulk of it, it is powering AI with gas power plants. So how are you guys thinking about it? Is it what Mihir is basically saying, that you are beholden to your shareholders, and if the policy environment is stringent on environment, and if there's a carbon price and stringent air pollution regulations, as companies you will respond and not build all these gas power plants, and so how are you guys thinking about it?
Yeah, thank you so much, Amol, and thanks, Mihir, for the perspective. I think one of the things across hyperscalers that we have been prioritizing over the past couple of years, and even more now, is the standard metrics and the standardization around how we estimate the overall energy footprint here. So, in a lot of cases, we are still evolving and understanding how the AI footprint should be measured against how much we are consuming. And that requires significant amounts of open contributions as well as open source research. We are doing that as part of Open Compute and with research partnerships across the academic groups. What this is helping us do is standardize metrics for reliability, carbon estimation, utilization taxonomy. I think all of these are going to be the ground making foundation for how we propel these studies to set up and stand these large scale data centers. Because any amount of governance that we can provide as part of setting up this infrastructure, that is what is going to be used for the long term, for the next few generations, to understand where we could be standing these resources. And this research is intended to globally benefit the entire industry as we collectively strive to reduce the consumption and meet our demands responsibly.
So thanks, Richa, for that answer. Definitely, those things would matter. Deepak, you have been, it appears that you have kind of dealt with the utilities the most probably amongst this group. uh, what do you think is realistically possible on powering AI sustainably, given all the infrastructure constraints, the reliability requirements? And if you were to tweak the direction of its primarily being powered by a lot of gas power generation, what would you do? What would be your advice? And also give a sense of realism. On one hand, there is a net zero, we're going to do all clean commitment. On the other hand, it's all gas powered. Like, I'm not able to figure out what the hell is going on. And is it just companies responding to the broader policy environment, or is there a place for innovation? I mean, you worked in this field, so just give us maybe your tight top lines in terms of how would you push this to become more sustainable?
I think, Anmol, I think all of us will be, and all are agreed on one thing is the money will drive any policy, whatever you want. Yesterday we were talking about climate, today we are not. Tomorrow we'll start talking about the climate. I'm not saying it's not a reality, it's a reality for all of us, right? And Mir already talk about certain point from the how this used to be a one-way grid become a two-way grid, where your generation is variable, your demand is so variable, right? So I will, and I know Richa is on the call. I don't want to make this, statement, but the point is Google, Meta, OpenAI, all of them are really pushing because they know that there's a money demand. They all want AI to compute. Everybody wants people to leverage the AI for definitely either solve the problems, real problems, or just solve the problem. So there's a demand, there's a money, they will dictate it. The world of the data center is really driving all this demand. But when we take it ourselves, and I'm being very realistic about it, the AI cannot be think, or the climate cannot think without a people. It's impacting people, and impacting people affordability. I know I don't want to talk, in context of the alignment with the government's A, B, and C and D. The affordability is the most important context here. If as a people not able to afford today, it doesn't matter AI or the power, water, what is really requirement for the people. The people need to be living at home, so that and to live at a home they need a power and water to live, and then they need to have a good climate. So if we put this across, it's a multi-million variable equation to balance it out. And I feel at this moment when we've been working with utilities, global utilities, energy and utilities companies, irrespective of that, is the last 50 years, what Mir also said, optimize as much you want. And Richa said the same thing, that if Meta and Google and all those big companies have a big money to do, if they optimize the energy and water usage, and able to work with the industry and the people, and the three angle comes together, that's the only solution, because one
Right.
cannot solve the problem. And again, I'm being very open, the government will get dictated, policy will get dictated by the money, the economics will teach. Doesn't matter what, all of us have to be factual. Is if somebody you made a very important point, Utah, right? I will give you 10 more articles where the utility companies stop in right now in Arizona state, and both the APS and Dominion, both energy utilities run on our platform. We connect to, we empower them for all the demand supply. They're not allowing data centers to be built. They say, okay, you can have billions of dollars. We will not allow you in Arizona because we don't have any water and power to give it to the people. And so I think in the nutshell, it is a three pillar problem. It has to be people in the middle with affordability have to be taken into account to solve this problem in a short term and long. It has to be energy optimization and water conservation in the core of the core, and that can be solved through a vertical AI platform mindset. And I know for sure
Got
me.
it, got it. No, I think,
Yeah.
thanks, Deepak, for your perspective. So what I'm hearing from the panel is that, yes, there is this reality of a gas build out. What Mihir is saying is that that is also being driven by the policy environment. So if one would to kind of change or impact the policy environment, then the private companies will respond. Richa has kind of nicely articulated that you need clear measurement and governance frameworks. But what Deepak is saying is that that policy environment is not just a static thing. It's driven by the money. It's driven by the interest of the data center companies. So I do feel that my own take is that uh, clean energy also has now the aspects in certain levels that it can be built quicker. Yes, you can build all the gas turbines and the aeroderivatives are coming up, but if you want to actually a regular natural gas power plant, there is a 5 to 6 year wait of getting those turbines. There are only three major manufacturers of building those turbines. So even if I do believe that with creative solutions, there is a way to align the speed need of AI companies with clean energy, because it can be built faster. Because that kind of gets up. Because I don't believe that in the very tough race of getting compute, that is probably the biggest priority of the data companies. Environmental aspects are a nice thing to have, but it's not the where the shareholders are demanding accountability. So if there is a way to align some of the beneficial aspects of clean energy, which is speed and maybe more acceptance amongst the community with the needs of data centers, the problem could be solved. I know we are a bit short on time. So I want to kind of quickly do two things. First, I want to get any kind of ideas, say Mihir you have, others you have, is that we do have a big choke point in terms of getting large amount of clean energy integrated into the grid. There are interconnection studies take forever, transmission build out takes forever. So if you are able to be very precise about what are one or two big solutions that you see to address the faster integration of clean energy, that would be great. And anyone who has a bright idea can jump in as well. And lastly, I want to kind of bring out that Indian critical parent in you. If you happen to be around one, or if you are actually yourself one, I want to give you guys as a parting remark. I want you guys to give a grade of how we are doing. Is it C minus? Is it F? Is it B plus? And where do you think we can be by 2030? So I am not gonna. So first, over to you, Mihir and Richa and anybody who, I don't. I want actually a solution of. Do you have any bright ideas how to integrate clean energy faster or kind of match the infrastructure timelines with what AI needs? Over to you, Mihir.
So I think just to complement the discussion, and thanks for opening up, Amol. There's been a report by Eric Schmidt that came out a few days ago saying that he sees and he advocates for a decoupling of the grid from the energy sources required for data centers, especially for the resiliency of local communities. And I think the aspect that is really important to us is public acceptance of infrastructure projects in the energy sector. So I'll give an example of something that goes beyond the use of AI for optimization of forecasting, which is not around really the technology itself, but actually around getting projects approved and accepted locally. So Professor Majumdar also mentioned it as something that's a roadblock for speeding up the deployment of new energy projects, especially green energy projects in territories which have, sorry, uh, sorry, which have a large footprint in territories and have an impact. And we all know this acronym NIMBY, which is not in my backyard. The fact that people support the energy transition as long as it doesn't affect their view or the cost of their homes, etc. So we've been working on a tool that's called Stakeholder Suite that uses AI to understand how opposition from local communities, NGOs, or regulatory complexity from local policymakers can face delays of months or even years. We've seen the time increase between permitting and actual construction of projects. So what we do is to use AI to analyze public data like local press, policy documents, social media, institutional reports, And we try to not only identify the key actors, their relationships between them and their degree of influence, but also understand their positions and the arguments across multiple dimensions like economical, social, ecological, and track how their sentiment evolves over time. So what we do is to support the project teams to anticipate those concerns and engage more constructively with those stakeholders. And I think that's one of the things where we see a very tangible impact in terms of reducing delays, increasing resilience here across the project that are being developed. And really the two pillars that we see development of AI in the infrastructure sector are on one hand using AI for assets, for equipment, for some sort of augmented digital twins to optimize the system themselves, and we think of
Great.
them as system of systems. And the other one is AI for people, is how do we augment the processes in the way that people operate those assets, the way of working, the way that they're going to model their processes and programs. And those two pillars are sort of where the new AI technologies coming up around agentic and world models, those kind of things are really helping out. So it's a
Great.
combination of cutting edge AI with the energy transition.
No, thanks. So I think we are kind of running out of time. So I would suggest Richa and Deepak, just give me your 30-second version, and to keep it entertaining, give you a grade.
Yep.
And I want to close in another next 2 minutes.
Yeah, I think on the grade itself, Amol, I would give it an A minus right now. The reason I give it an A minus is because we see like there's a lot of scope of growth and opportunities where we have the ability to optimize more. Just to give an example, since you mentioned about the transition time to clean energy, we are constantly working on the infrastructure side to make our infrastructure layer as much agnostic of the sourcing of energy where we are getting it from, because right now grids are stable, like we kind of expect.
Awesome, Richa. Sorry, I have to cut you off, but
Yeah,
I
no,
want to
no
get
worries.
Deepak. Sorry, really sorry. Deepak, uh, tough job, 30 seconds and great. And then we close the panel. And if we can answer a few questions, because I don't want to kind of run over the other sessions. But thank you, folks.
Amol, to my point, all of us covered that. It's no more regulatory problem. It's no more state and government problem. It's no more energy utility problem. We need to take the intelligence, the AI, to the millions and billions of people, because if they optimize, if they have a
All
right,
right, great, Deepak.
that's where it is. Okay.
Thank you.
Cool, bud.
All
Thank
right, awesome. I'm happy to take any questions, but we are also running really short on time. So I will leave it to Amita how you want to handle this.
Actually, we could go on. There are so many questions that we have also seen in private messages come up, but we are a little short on time, and our final speaker is on a tight timeline. So I'll let you guys wrap this up with our immense gratitude, Amol, Mihir, Richa, and Deepak. Thank you so much for joining the event and for your support of Indiaspora.
All right,
you.
thank you, guys.
Thank you.
Thank you. All
Thank
right.
you.
Bye.